Hello and welcome back to the Innovators Tomorrow, and today we're going to have a close look at one of the learning resources we have on the website. So I'm going to go into the Learning tab, and at the first resource you'll see it's a problem solving versus exercise solving table. Now this provides a good explanation of the difference between problem solving and exercise solving, particularly in mathematics. Now this is not a resource we created. We got this from the Griffith University, who had lots of problem-solving resources to do with PISA, and where we gained some of our information for our project. Now, if you look closely at the exercise solving side of this table, you'll see that it explains exercise solving as the typical word problems that people would be used to. Now, teachers need to realize that there is a difference between those word problems and problem solving themselves, and both of them have a place in the mathematics classroom. Exercise solving is very closed. It's usually looking for one answer and the right answer. There's usually generally one process in order to get that answer. Sometimes you have multi-step exercise problems where there's multiple ways to get to an answer, but still you're looking for the one right answer. Their situations are usually well defined and explicit in order to find the answer to that exercise solving problem. They're usually the problems that students are used to seeing. They've come across them before. They see them in NAPLAN tests. They see them in textbooks. They see them on worksheets. The teachers are usually looking for one right answer, and the emphasis is on finding the answer, not the process to the answer. And this usually leads to not much communication skills being used in the process of answering an exercise solving problem. Now, problem-solving problems, on the other hand, are completely the opposite. They're very open, and they're looking for the one right answer. They're looking for a best solution to the answer, where students need to reason and argue and debate in order to convince others that their answer is the best answer. Their situations are usually not well defined, meaning the students are working in the ambiguity, working in the unknown. In order to do that, they actually have to communicate a lot. So they have to ask questions of the teacher and the students in order to find more information. And it's more of an investigation to find a solution rather than finding that one solution that the teacher or the student's looking for. I will warn you, though, that this is very hard for some students, especially in the later grades and in high school, because they're not used to working in mathematics in that way. They're used to finding the one answer that the teacher's looking for. And with problem solving, algorithms are just a way to help their reasoning for the answer. They're not the way to find the answer. And that all leads to more oral and written communication for the students in order to argue with others and debate with others that their answer is the best answer. Now, I'm going to show you an example of a way that I've done this in the classroom. And I've actually taken this question, which was a Year 3 NAPLAN question in 2015, which is an example of an exercise solving problem. Now, this is a word problem that many teachers in primary school would be familiar with, and it's a basic addition word problem. But you'll see there's one answer to this problem. And if I go to my photos, and I'll show you an example in my classroom where this is their working out for that problem. It very simply just asks them to find 8 plus 5 in order to find the answer of 13. And that's all my students show on their working out. You see they did this in about 10 seconds. There's no communication with other students in the class. And if I just look at the other examples in my class, this one, they tried to show some problem-solving strategies in order to answer it, but it's still 5 plus 8 equals 13, no communication with other students. And that's an example of an exercise-solving problem in the way they worked it out. You'll see another example of I've taken that example and turned it into a problem-solving problem. Now, to go back to this question, they're talking about Bella and the friends they invited to the party. Now, I always use the ideas of Dan Meyer, who says, use multimedia, encourage student intuition, ask the shortest question you can to make sure it's a mathematical question, not a reading comprehension question. Let the students build the problem, and then be less helpful as a teacher. Now, use my example here. You can see that I've asked the shortest question possible from the NAPLAN question. And it just asks, how many friends does Bella have at the party? Which is basically what they're finding out in the other one. But you'll see from my students' work, what happens straight away is that the students whinge about not knowing how to answer the question. They're straight away going to ambiguity. And the question is an open question without finding a simple answer. And from that, I normally encourage the students to start asking the questions that they want answered. And the next lot of photos you'll see are some of the questions that the students in my class started to ask about that problem in order to form their own problem within the bigger problem. And they asked questions such as how many friends did she have? Was she popular? What school did she go to? How many friends did she have at school? Was she friends with just boys and girls? Did she dance on the weekends? Did she play netball on the weekends? And all of these have an impact on the amount of friends that she would have. Now, I always add in a little bit of extra information so the students have numbers to work with. I'm working with Year 4 students in this case, not high school students, so sometimes they need an extra encouragement just to see a number to help them work with. But you still need to make sure that these are working in ambiguity where the students are forming the problem themselves. So in this case, I've just said she does dancing, she does play netball, she goes to school with 600 students, and she has a brother and a sister. Now it's up to my students in my class. Again, they're going to start asking questions, and this time they're going to start using those numbers to come up with an answer that they feel is the best answer for them. And in this case, I'll show you some photos of the answers they came up with and their reasonings for those answers. And you'll see that there's a lot more working out than in the original 8 plus 5 equals 13. In this case, they're talking about how many friends they would have in their netball team. Up the top right here, they're talking about halving and division. In the class, as I said, there's 30 kids in the class and 13 of them are girls. Now, this is all formulated by the students. They're forming this problem themselves. So they're using subtraction, division, and down the bottom, they've come up with their addition algorithm in order to find their final answer of 37. Now, they have to use these, and after they've come up with their answers, they need to argue and debate their answers within a small group and agree on a best solution to the problem. And this example, you see, has got amount of kids in the netball team. They've minused one of them away. 30 kids in the class, take away 7 that they would invite. They've plussed it on to the 7 originally. So they've come up with an answer of 32 because of the siblings. And that would be that person's solution to the problem. This one, again, they've divided into different sections of where they would get the friends from, added them together and come up with the final answer. Now, that involved a lot more communication and talking with each other and asking each other the questions and how many kids are in a netball team and how many kids are in a class and how many girls are in our class. And all of a sudden, they start forming their own problem. And there's no right answer, one right answer. Now, that's just one example of how you can take an exercise solving problem and turn it into a problem solving problem, and make sure that you're trying to stick to the differences between the exercise solving and problem solving if your focus is on problem solving. Thanks again, and look forward to making more videos explaining some of the resources we have on this website. See you later.